Hi there. Let me take you through my solution for the first of the AP practice free response questions for nonlinear models and categorical data for our review for our next test. So the idea here is you're given a set of data regarding the production year of a particular make and model of vehicle and the asking price advertised for used versions of this make and model. So 3 models have been fed. You're given all of those data, all of those printouts. So the first model is a standard linear regression model where year is the explanatory variable, year of production. Here is the slope, here is the intercept, and then the output is the estimated price for that used vehicle. So the second model, here it is. The second model uses year as the explanatory variable. Here is your slope and here is your intercept, but notice then the output is the natural log of price. So this represents an exponential model. And the last model, model number 3, this is one that although it appears on this question, it's no longer part of our curriculum. So it's certainly though a model that we could still handle. So notice this time the year, the input is equal to year times 0.176 plus negative 13.3, this gives you the square root of the price. So these are the 3 models that you're given, and you're asked in parts A, B, and C to simply use those models to establish an asking price for this 1988 vehicle. So all you have to do for all of these, I've written out the models carefully. So here's part A, the linear model. All you have to do is put 88 in for the year. So you actually would want to take the time to write this out. Your estimated price would be negative 58.1 plus the slope of 0.719 times the 88, and that will give you your estimate. Of course, you can just type that right into the calculator on the home screen. Here's the negative 58.1 plus the slope 0.719 times 88. And again, I can see from the scale on my graphs that the year is in 2 digits, so I don't have to enter the 19. So 5.172 is my estimated price, so that would be $5,172. So that would translate into $5,172. So that would be for the linear model. So continuing on then, for the second model, in part B, this would be an exponential model. So I have to take the negative 14.9 plus 0.185 times the 88, but then notice that's going to equal the natural log, I'll call it P for price. So after I do that calculation, I'm still going to have to work with an exponent here. So I'm going to go to the calculator. I'll put this in as the negative 14.9 plus the 0.185 times 88. So that gives me 1.38, but I am not done. That does not suggest $1,380. That 1.38 then, need a little bit more room here. So my price estimate, the natural log of that price estimate is the 1.38. So I still need to convert that into a price that I can interpret. So I have e to the power 1.38. That is going to give me my price estimate. So on my calculator, second logarithm will give me my e, put in my power of 1.38, and there it is. So let's call it $3,975. There we go. Again, 3.975, $3,975. So part C, to do this estimate, again, same as before, I need to put in my year of 1988. So I'll start with the negative 13.3 plus the 0.176 times the 88. But what that's going to give me then is the predicted square root of the price. So I'll call it P, my predicted square root of P. So I need to plug that into the calculator, see what I get. So I got my negative 13.3 plus 0.176 times 88. So that gives me 2.188, but I am not done. So I need a little bit more room. I'll scoot over here. So the square root of my price, that prediction, oh, forgot what it was already, 2.188. So in order to come up with my price, I need to square both sides to undo the square root. So my estimated price is approximately, again, if I square both sides to get rid of the square root here, the 2.188 squared, 2.188, I'll square it. That gives me, let's call it $4.787, $4,787. So, shouldn't be surprised, based on different models, I get 5 different suggestions as to what my estimated price for this used car should be. So part D is asking, describe any shortcomings that you see in these models, and all 3 of them have essentially the same problem. So notice all 3 of them, if you look at their residual plots, so this is residual on the y-axis, and here's the fitted values on the x-axis. Again, I see a curved pattern here, which makes me suggest that the errors, there's a pattern in the errors here that's not accounted for by the linear model. Similarly, in model number 2, again, it's not quite so severe, but I still see a pattern in the errors here. We start by under-predicting, we're over-predicting, and then we end up by under-predicting again. I see the same thing in the 3rd model. So again, considering the residuals, we are under-predicting and then over-predicting and then under-predicting again. Frankly, I'm not happy with any of these models based on the residual plots that I see, even though all of them have high values of R squared. So something to think about, the linear model, 88.5% of the variability in price is being explained by this linear model using the production year. So that's a relatively high R squared value. Same thing for the exponential model and the model with the square root for the output. So the exponential model gives me an R squared value of 94.6%. The model involving square roots is at 91.9%. So notwithstanding the fact that we're explaining a large percentage of the variability in my response values, because the residual plots indicate a pattern, that suggests that really none of these models are a particularly good fit. So at this point, in part E, you're asked, use some or all of the data to find a better way for establishing an asking price for your 1988 automobile, and then explain why this method is better. Well, if you go back to the scatter plot for the linear model, notice what I see when I look at this scatter plot. Essentially, I see 2 lines. So here are the observations for 1979. Here's an observation for 1982. Here's an observation for 1984. These values are rising at a relatively shallow slope. And then starting here with this observation, 1985, or maybe you could start with the 1986 observation. Either one, I suppose, would be acceptable. I'm going to start with the 1985 observation right here. Then it looks like we have a new linear trend with a different slope, with a steeper slope. So maybe a better way to estimate the value of my car would be just to consider these data that follow this linear trend, of which my 1988 would be a part. So I have entered into the calculator the data values for that portion of the data. So if we go to Stat Edit, so I've started with the observation from 1985 with the corresponding price of $1,500, and I have included all the data through, I think the last observation was for 1993, there it is, with a corresponding price of $9,800. So I suggest we just run a straight linear regression based on list 1 and list 2. So we can go to Stat, Calculate. I'll choose my option number 8. I want to use list 1 and list 2. This is a plain linear regression. So we'll go to calculate. Very good. So notice here is my constant, the negative 87.28. The slope is 1.04. Notice the value of r squared is quite high. It's 0.978. So 97.8% of the variability in price is being explained by this linear model using production year as the explanatory variable. So I've taken the time to go ahead and write this model out. This is something that you would want to be able to do. So here it is, y hat is equal to the intercept plus the slope times x. Again, make sure you say specifically what x and y represent. So it's interesting, the question didn't ask you to actually make a prediction. It might be interesting to go ahead and make the prediction. Hey, another thing to consider, not only is the value of r squared higher here, but it would be good to go look at the residual plot also to see if we've in fact built a better model. So let's go into plot number 1. So I'll leave list 1 alone, and I'm going to put in my residuals. So hit second stat and go to the resid list. Put in my residuals here. Oop, I hit the wrong one. Go back in, second stat. Go to residuals. Here we go. We'll zoom 9 this. Oh, I'm much happier with that. So there's a scatter plot where I don't see a pattern with regard to where I am over or under predicting. So I'm much more happy with that scatter plot. That's relatively scattered. I don't see a pattern regarding the errors here. So I can have confidence in this model. Interesting, you're not, again, like I was saying before, you're not asked to actually establish the price. You're just asked to find a better model and explain why this method is better. I would offer it's better because certainly the scatter plot isn't suggesting that the errors are predictable. It has a higher value of r squared, and it certainly follows the linear trend that we saw in the plot. So bottom line, just for fun, I'm going to go ahead and make the prediction. So if I go back to, again, my model here, if I wanted to predict the value of my 1988 automobile, I would just plug that in. So there's the 87.28 plus the 1.04 times the 88. We'll just plug that into the calculator, come up with our prediction. I'm just curious to see where it is. So negative 87.28 plus my 1.04 slope times my production year of 1988. And there's my prediction, 4.24, which represents $4,240. Very good. So bottom line, that question I would offer is a little more work than what you would be expected to do on your unit test for our course or on the AP statistics exam. Again, this particular practice question is a very old practice question, and the exam has evolved since then, but it gives you the same basic ideas. Again, you can read the model out of a table from computer output. You should be able to consider what the residual plots mean. You should be able to use models to make predictions. So those are the main skills that are important here. Hope this one has been helpful.